Hey everyone, how's it going? Sandustry has just landed in early access, and behind its cute pixel sand graphics lies a surprisingly deep automation system. The problem is that the learning curve can be deceptive. Setting up a basic line of shakers and conveyors during your first few hours is easy, but truly optimizing, squeezing out the maximum gold per second, and scaling your factory without it turning into a clogged sand mess is a whole different story. That's why today, I've put together 10 advanced tips that go far beyond the tutorial basics. I'm Mary, and let's get this factory properly optimized. The game isn't just about connecting machines, it's about understanding how each material behaves within the system, and advanced filters are the tool that turns chaos into control. If you're enjoying Sandustry and thinking about picking up the game, check out Instant Gaming. Right now, it's 46% off, which is the best price I've found so far, so it might be a great opportunity to grab the game for cheaper. And if you do decide to buy it, using my affiliate link in the description would be hugely appreciated. It doesn't cost you anything extra and really helps support the channel. Now, let's get back to the video. What makes the strategy so powerful is that it works with physics, not against it. Since denser materials like gold and slag naturally sink in sand piles, setting the filter to allow for the heaviest and block for the rest takes advantage of this natural behavior. You aren't fighting the game, you're using the sedimentation mechanics in your favor, which reduces bottlenecks and prevents that classic clogging from poorly separated mixtures. Another point many players miss is that advanced filters aren't just for solids. They handle mixed flows of solids, liquids, and gases simultaneously, meaning you can create processing lines that separate water, steam, and waste in a single pass. This is crucial as you scale into later stages where complex chemical reactions between sand, water, and ice generate mixtures that would jam conventional filters. Mastering this density-based allow-block technique is what allows you to build factories that truly breathe. Clean flows, less rework, and more gold per second. It's the kind of invisible optimization that only becomes obvious after spending hours tweaking conveyor belts, only to realize the issue wasn't the machine, but the order in which you were filtering materials. This efficient slag cycle tip is one of those secrets that completely transforms your factory's economy in Sandustry. Early on, it's tempting to treat slag as garbage. After all, it's just a byproduct of the gold separation process, right? But anyone discarding it is literally throwing valuable resources away because raw slag holds far more potential than it seems. The trick lies in understanding that unburnt slag is merely a raw material. When you run it through a flamethrower or use trapped lava to create burnt slag, you trigger a chemical transformation that unlocks components trapped within the original material. It's as if the game is telling you, nothing here is waste. Everything is just a resource at the wrong stage. This total recycling mindset is what sets amateur factories apart from optimized ones. The kinetic slag press is where the strategy truly shines. By processing burnt slag in it, you extract not only extra gold, which directly boosts your income per second, but also spores, which are essential for advanced research and unlocks. This loop of slag into burning, into pressing, into gold plus spores creates a feedback cycle that keeps your factory productive even when your main mining lines are undergoing maintenance or expansion. Mastering this cycle is all about systemic efficiency. You maximize the yield of every gram of processed sand while reducing the need for waste disposal and management, which quickly becomes a major logistical headache in large-scale factories. It's an optimization that looks small on paper, but in the long run separates early game survivors from end game masters. Instead of draining your power grid on pumps and drones to move water to the upper floors of your factory, the game invites you to think like a real engineer. Use physics to your advantage. Boiling water, turning it into steam, and letting it rise naturally isn't just cost-effective, it's satisfying to watch. What makes this technique so brilliant is that it leverages the natural cycle of states of matter within the game's engine. Steam rises because it is less dense, condenses when it hits colder layers at the top of your build, and falls back down as rain, ready to feed your shakers. It's a self-sustaining closed loop, and once you grasp this, you realize hydraulic pumps are a beginner's solution. A true Sandustry master lets thermodynamics do the heavy lifting. This phase change mechanic, solid to liquid to gas, is central to the game, and mastering these transitions is what separates power-hungry factories from those that run almost organically. When you design production lines around how materials can change states to simplify transport, you stop fighting the game and start flowing with it. Over time, this approach saves not just energy, but also space and logistical complexity. Fewer pumps mean fewer points of failure, less maintenance, and more resources available to expand other areas of your operation. It's the kind of optimization that feels like magic the first time you see it work, and becomes indispensable once you scale to multi-floor factories. The lava thermal buffer tip is the exact solution you discover only after wasting hours trying to figure out why your refineries keep fluctuating in temperature and stalling mid-process. At first, we tried to solve everything with direct heat sources, but Sandustry punishes that approach with sharp temperature drops that interrupt chemical reactions and waste valuable resources. The secret is thinking like a thermal systems engineer rather than just someone hooking up machines. Creating a lava pool with a large surface area works because it acts as a stable heat reservoir, far more reliable than point sources that deplete quickly. Connecting this pool to your machines using thermal buffer blocks creates a distribution network that maintains a constant temperature even during demand spikes. What many overlook is that the thermal buffer isn't just a hot block. It actively stores and distributes heat, allowing you to set up entire self-regulating thermal zones. Lava, or lit cinder trapped in a filter, is the most stable heat source because it maintains a steady temperature without drops, making it the gold standard for burner belts and advanced thermal processing. Mastering this technique is all about systemic stability. A well-sized lava pool with proper buffering eliminates the temperature peaks and valleys that disrupt production, letting your refineries run at maximum throughput without interruption. It's an invisible optimization. You don't see the buffer working, but you feel the result in every process that no longer stalls halfway through. Early on, we only use launchers to toss items upward occasionally, but once you realize they form the backbone of vertical and diagonal logistics, your entire factory layout philosophy changes. What makes launchers so powerful is the precise control you have over the launch trajectory. Mouse drag height isn't just a visual aid, it determines exactly where the item lands. Mastering this allows you to create transport paths across multiple floors without needing complex stairs or elevators. It's pure physics applied to logistics, and once you internalize the relationship between drag distance and trajectory, you start spotting layout possibilities that previously seemed impossible. Here's a crucial shortcut many take too long to discover. The Control Replace hotkey is a lifesaver when upgrading lines to Mark II. Instead of tearing down the entire setup and rebuilding from scratch, a nightmare in dense factories, simply hold Control to upgrade while keeping the exact configuration intact. This saves hours of rework and lets you scale operations without halting production. While starter factories tend to be flat and horizontal, optimized ones exploit vertical space intelligently, and launchers are the key tool for that. Combining pinpoint trajectories with quick hotkey upgrades creates transport systems that are both elegant and efficient, the exact setup that makes you feel like a true automation engineer. Mass blueprint creation is easily one of the biggest time savers you will find. At the start, we place everything piece by piece, every shaker, every conveyor segment laid manually, which works fine until you need to scale. When the time comes to expand into multiple production modules, discovering the built-in copy system changes everything. What makes this mechanic so powerful is its precision. Pressing C to select an existing structure and using Control-C/Control-V isn't just about speed, it's about consistency. Every copy preserves exact component alignment, ensuring replicated modules perform identically to the original. This eliminates the misalignment errors that happen during manual reconstruction and guarantees uniform efficiency across all production lines. Another detail easily missed, you can export these blueprint strings and share them with the community. This opens up an entire ecosystem of ready-made designs, from optimized shaker arrays to complex processing lines. It turns the game from an isolated solo experience into a collaborative one, where you can take proven setups from other players and adapt them to your factory. Instead of treating your base as a single, sprawling build, you begin planning in modular, repeatable blocks, shaker arrays, belt segments, and refining units that can be pasted as demand grows. It's an optimization that seems simple on paper, but in practice saves hours of construction and lets you focus on what really matters, expanding and refining your operation. This tip is one of the smartest setups you can build early on, as it turns a major bottleneck, clean water for sand washers, into a virtually free automated resource using the game's creature mechanics. The core concept relies on the Corraler tool to capture lumlings, the small cave creatures tied directly to water generation. Instead of depending strictly on rain, pumps, or manual reservoirs, you build a creature farm, a secure enclosed containment area holding multiple lumlings together. Inside the space, they generate water passively and continuously, feeding your sand washers without requiring manual intervention. From an optimization standpoint, this heavily streamlines your layout planning. You can place this lumling farm right next to your washing area and run short pipes and pumps to distribute the water reliably, minimizing downtime from resource shortages. Because the generation is constant, you gain the headroom needed to scale more washers, ramp up wet sand production, and ultimately yield more gold without worrying about the operational overhead of sustaining a water supply. If there's one lesson that took me a while to learn, it is that filtering in the wrong order is like trying to fill a leaking bucket. You might still be producing, but you are losing far more throughput than you realize. Worse, the fault doesn't lie with your machines, but with the order in which you are separating materials. The game's physics strictly enforces density. Gold, slag, burnt slag, all of these sync naturally. If you configure an advanced filter to allow the lighter material first, the heavy material gets trapped underneath, piling up, causing jams, and eventually collapsing your entire line. The solution feels counterintuitive at first, but makes complete sense once you see it running. Always filter for the densest material first. Set your allow filter to gold, to slag, to whatever sits at the bottom layer. The rest follows after. This isn't just an optimization trick, it's a fundamental mindset shift. Mid-game advanced filters aren't meant to isolate one element at a time in isolation. They are built to manage chaos, solids, liquids, and gases all mixed together. The only way to process this without creating bottlenecks is respecting the natural order: heavy on the bottom, light on top. Allow at the base, block for the rest. Simple as that. Once implemented, the difference is massive. Clean separation, consistent throughput, and minimal maintenance. Your factory stops looking like a failing alchemy lab and starts running like an industrial machine. Best of all, you realize the game isn't punishing you, it's just asking you to think like an engineer rather than a button pusher. I used to treat every mixer like a coffee machine. Drop the ingredients in, hit the switch, and expect the finished product immediately. In Sandustry, that approach leads straight to frustration. Void bloom, wet spores, slag burning, none of these convert at a perfectly uniform pace. Material enters, a fraction converts, unreacted material stays behind, and suddenly a backup stalls the entire line. The real fix isn't speeding up the machine, it's recirculating the feed. A simple one-block-high closed loop changes everything. Dense materials sink, fully converted products get filtered out, and unreacted material loops back into the process. There is no waste, no buildup, and no missed conversions. Anything that fails to react on the first pass gets a second, third, or fourth cycle until fully processed. It sounds like a minor detail, but it represents a structural shift. Instead of fighting incomplete conversion rates, you design around them. The loop doesn't attempt to force 100% single-pass efficiency. It lets the system process at its natural rate, extracting maximum yield without generating bottlenecks. It feels less like rigid assembly and more like gardening. You plant, let it grow, harvest what is ready, and leave the rest to finish developing. The result is a factory that breathes freely. No blockages, no manual clearing, and no feeling that you are constantly putting out fires across production lines. Watching void bloom output steadily, wet spores flow, and slag burn down completely makes it clear that optimization isn't about slapping down more machines, it's about letting the ones you have run properly. It took me a long time to understand why my conveyor belts kept jamming despite having plenty of open space. The issue wasn't a lack of capacity, it was excessive flow height. When material is allowed to stack freely, dense pixels sink and form a compressed bottom layer that blocks everything above it. Flow locks up, throughput drops, and upgrading belt speed does nothing to solve the underlying problem. The counterintuitive solution is to restrict flow height to exactly one block instead of letting material pile up. Use filters or containment walls to enforce this restriction ahead of critical choke points like shakers, presses, and launchers. While it might look like you are throttling capacity, you are actually establishing flow consistency. With only a single layer of depth, dense material cannot sink and pin down lighter particles. Everything moves at the same velocity, arrives together, and processes without jamming. This changes how you approach production line design. Instead of assuming taller is better, the rule becomes more controlled is better. A belt restricted to a one-block height isn't less productive, it is predictable. That predictability enables shakers, presses, and launchers to run at peak throughput without stalling for material or clearing backed-up piles. The throughput gain is substantial. Seeing material feed in steadily without drops or jams proves the bottleneck was never the machinery, it was improper feed regulation. Capping flow height works like regulating water pressure before opening a valve. It's about delivering the right volume at the right time in the right way.